Good day! For today's lesson is all about ionic bonding. But before that, let's review first our previous lessons. First is about the periodic table. The shade of pink, these are elements under metal. The shade of blue, these are elements under non-metals. And the shade of green, these are elements under metalloid. This time, let's identify the difference among these three terms: atom, molecule, and ion. When we say atom, all these elements on the periodic table are called atom or neutral element. Except these elements called diatomic molecule. What are these? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Again, all the elements on the periodic table are called atoms except for those elements called diatomic molecule or diatomic elements. So what is a molecule? A molecule is an electrically neutral group of two or more atoms held together by chemical bonds. Molecules are distinguished from ions by their lack of electrical charge. Therefore, when we say ion, it has an electrical charge. It could be cations and anions, the positive and the negative charge. So all the ions found on the ionic table are example of ion. Lastly, let's recall about covalent bonding. What is the chemical name of the following? So given is the chemical formula. First example, we have NF3. So input first the prefix used. 3 is tri, and the element name for N is nitrogen. Tri, F is fluorine, the root name is fluor, and ends with IDE. So the answer is nitrogen trifluoride. Second example, the number of atom of selenium is 1, and the same thing for chlorine, also 1. But since we can't use mono on the first word of our answer, only on the second word, so input mono on the second word, and Se is selenium and Cl is chlorine, so therefore selenium monochloride. Third example, we have di and octa. Input first the prefix. H is hydrogen and Br is bromine, and that is bromide. Next is, what is the chemical formula given the chemical name? First example, diphosphorus monoxide. So PO, the symbol is PO, and the prefix is 2, di is 2, and mono is 1. So therefore, P2O. Next example, tetracarbon hexaiodide. Carbon is C, iodide is I, so Ci, and let's identify their prefixes. Tetra is 4, so C4. Hexa is 6, so I6. The answer is C4I6. Last number, we have carbon monoxide. So identify first the symbol of the element. We have carbon C, oxide is O. Since the number of atom in each element is only 1, so therefore the answer is only CO. Now, let's talk about ionic bonding. It is a combination of metals or called cations and non-metals or called anions. We have here the symbol M plus N or C plus A. For ionic bonding, we will be needing this ionic table. Let's understand more about ions. This is called element symbol or chemical symbol, and the element name or chemical name. Also, what is monatomic ion and polyatomic ion? When we say monatomic ion, majority sa cation kay monatomic, except sa ammonium, mao ni ang polyatomic sa atong undercations. Observe ammonium, it is composed of nitrogen and hydrogen. So, poly kay composed of 2 elements. Monatomic, only composed of only 1 element. So, for anions, daghan kaayo ta og polyatomic. Polyatomic ion for under anions ends with ITE or ATE. Example, borate, bromate. Borate is composed of boron and oxygen. Bromate composed of boron, bromine and oxygen. And the monatomic ion ends with IDE. So we have bromide, iodide, nitride, sulfide, oxide. Those are the example of monatomic ion. Cations are metals with charge, anions are metals with charge. The number of charge indicates the number of electrons that will lose or gain during a chemical reaction or ionic bonding. Let's say aluminum has 3 charge, therefore aluminum will lose or muhatag siya og electrons, muhatag siya 3 ka electrons sa anion. For silver o sara, so na invisible 1 number of electrons. For bismuth, duha iyang electrons nga mahatag once ma-combine sa anion. For anions also, once arsenide is combined to cation, since the value of charge is 3, therefore 3 sad ang iyahang i-gain or ma-receive nga electron. For borate also, 3 ang ma-gain or ma-receive nga electrons. For bromide, only 1 electrons ang iyahang ma-receive. As well as sa bromate, only 1 kay more man iyang number of charge. Observe our cations. We have 2 options for naming cation. We have here ferrous or iron, ferric or iron. We have also another example. This name having Roman numeral is called stock name. And for this name, ends with OUS or IC is called classical name. So once you're asked what's the classical name of Fe having 2 charge, classical name, so you will provide ferrous. If you are asked to give the stock name of Fe3+, you will give iron 3. For naming or writing chemical formulas of ionic compounds, we will use this crisscross rule. But before I will show to you the process of crisscross rule, I will show to you first the visual illustration of how cation and anion combined. So let's recall the electron orbitals, the maximum of electrons per orbit or per shell. Sa first shell, we have maximum of 2. The formula to get the maximum of electrons, remember, in our previous lesson is 2n squared. For second shell, we have maximum of 8 electrons. For third shell, 18. For fourth shell, 32. Fifth shell, 50. Sixth shell or sixth orbit, we have maximum of electrons is 72. Let's combine sodium, our metal, and chlorine as our non-metal. Sodium has 11 as the number of electrons or atomic number. For a neutral element, the number of proton, atomic number, and electron is equal because they are still in neutral state. So let's have a table. For the first shell, we have 2, and second shell, we have 8. 8 plus 2 is 10. So what's left to make it 11 is 1. So we have 1 electrons on the last shell, or called valence electron. The other name for the last shell is called valence shell. Valence electron is the number of electrons on the last shell. Valency of element, when we say valency of an element, it is the number of electron nga ma-transfer sa non-metal. In this case, valence electron and valency of an element, sodium, we have the same answer, which is 1. So this is the atomic structure of sodium. Let's have chlorine. We have this right on our previous lesson. Chlorine, we have 2 for the first shell and 8 for the second shell. Valence electrons on the third shell is 7, and to get 17, add these electrons per shell. So we have 17. And let's have an illustration. So we have 7 electrons on the last shell. Once this sodium and chlorine, metal and non-metal combined, the electron on the last shell of sodium will transfer to chlorine because of the electrostatic force produced by these elements. That's why sodium will lose 1 electron and chlorine will gain 1 electron. And that's how ion produce from neutral state. And those ions on the ionic table, diun sa sila pag-discover nga nung mao jud ni ilahang charge kay for the series of experiment probably kung si sodium i-combine bisan asa nga anion, 1 electron ra gyud iyahang malus. And also for chlorine, bisan asa siya nga cation i-combine, 1 electron ra sad iyahang i-receive jud. The chemical name of sodium plus chlorine is called sodium chloride, and the common name is called salt. This time, let's understand what is a crisscross rule. Let's have an example. Give the chemical formula of the following compound. So given is the chemical name, we are going to give the formula or chemical formula. We have the first example, bismuth arsenide. First step, identify the symbol of each element or of each cation and anion. Bismuth is B2 plus and arsenide is this one. So copy. Next is apply crisscross rule. So what is a crisscross rule? Crisscross rule is the charge of arsenide will be the subscript of bismuth, and the charge of bismuth will be the subscript of arsenide. So this is how it looks like. And the final answer, itapad raning duha. And that's it. Second example, silver and borate. First step, identify the symbol for silver, that's Ag+, and for borate, BO3 charge 3 negative. And apply the crisscross rule, the charge of borate will be the subscript of silver. And what's left is the positive and negative. In mathematics, if we combine positive and negative, it will equate to 0 or makancel raman pud siya. Now, the answer is Ag3BO3. Now, observe the difference, class. Example 1 and 2. If our anion is polyatomic and our cation has more than 1 charge, therefore we need to enclose parentheses before we put the charge of our cation. For here, second example, since our charge is only 1, so there's no need to put parentheses. Kay as is raman gihapon. And also class, combining ionic bonding cation always comes first before anion. So cations jud ang maguna, then the anion. Third example, auric bromide. The symbol for auric is Au3+, and symbol for bromide is Br negative. Apply the Kresger's rule. Therefore, the final answer is AuBr3. Second set of example, we have here named the following chemical formula. So we are going to give the chemical name of the given chemical formula. First example, we have Mn3N3. So first step is identify the element name of Mn. We have manganose or manganic. Now, which is which? Take note that the subscript of our anion is the charge of our cation. Since we have 3 as the subscript of N, therefore Mn has the charge of 3, which is called manganic. So we will input manganic and N is nitride. The answer is manganic nitride. Second example, we have Li2MnO4. Li is lithium and MnO4 is either permanganate or manganate. Now, since our lithium here has a subscript of which is 2, therefore this subscript is the charge of MnO4, and that is manganate. So the answer is lithium manganate. Okay, ang subscript niya kay charge ni MnO4. Third example, we have NH4NO2. NH4. 4 is daan sa atong formula, which is ammonium. And NO2, wala nilaing subscript nga 2, that is nitrite. So the answer is ammonium nitrite. To give a visual illustration of this example, this is one of our examples. If we combine Au3+ and Br negative, this is the chemical formula. And the chemical name is, the classical name is auric bromide, and the stock name is gold-3 bromide. Now, the composition, remember, subscript indicates the number of atoms present per element. Auric bromide, the composition is 1 atom of gold and plus 3 atoms, Br3. So that's 3 atoms of bromine. On the ions, we know that once this cation combined to anion, once this auric combined to anion, muhatag jud siya og 3 ka-electrons. Remember? And this bromine or bromide, once combined to cation, mo receive jud siya og 1 electron. On the illustration, since muhatag man siya og 3 ka-electrons, tagsaan niya ang atong per atom sa bromine. So that's the illustration of the electrons transferred from cation to anion. So mulang gihapon the same ra, 3 ang na-release, ang na-lose nga electrons ni auric, and 1 ang na-receive nga electrons ni bromine. 1 electrons per atom. Okay, let's have more examples. Complete the table by providing the correct missing terms. On the first column, we have chemical formula, and on the second column, we have chemical name. Chemical name for SN3PO32. SN is either stannous or stannic, and remember we have here subscript of our anion which is 2, and that is the charge of Sn, and Sn2 positive is stannous or tin2, so that is stannous, and the PO3 is PO3 with a charge of 3, 3 negative, that is phosphite. So the answer is stannous phosphite or tin 2 phosphite. Second example, FeOH3. Fe is either ferrous or ferric, and we have here subscript 3, so therefore the charge of iron Fe is 3, and that is ferric. Okay, ferric, and OH is hydroxide. Therefore the answer is ferric hydroxide. Next example, PbCN4. Pb can be either plumbous or plumbic. Take note, we have here the subscript 4, and that is the charge of the cation, which is plumbic. So plumbic, Cn is cyanide. Next example given is the chemical name cobaltose chloride. So cobaltose, that is CO2 plus, and chloride is, where is it? Cl negative. Therefore, the formula would be COCl2. Good. Now, next example, we have potassium bicarbonate. Identify the symbol for potassium, that is K positive. And for bicarbonate is HCO3, charge is negative. And apply the crisscross. Therefore, the answer is KHCO3. And the last example, we have cadmium phosphate. Cadmium is the symbol for cadmium. We have CD, charge 2 positive. And phosphate is PO4, charge 3 negative. Now, apply the crisscross. The answer is CD3, PO4 parentheses 2, the charge of CD. And that ends our lesson for today.